Hi kids, it's Mrs. Geiger. Some people had asked me about this transformation efficiency. So I wanted to just record a short video explaining how you're going to do this calculation. Transformation efficiency is basically the idea that we should be able to quantify how many bacteria cells were transformed, how many of them took up and recombined the GFP plasmid into their cell structure, into their DNA, which would allow them to produce GFP. All right, so that's the idea with transformation efficiency. It's how well did the transformation work. So you're going to, so this is the general formula for transformation efficiency. And you'll notice here that it tells you that only 1 in every 10,000 cells actually gets transformed. That's the reason for the heat shock. The reason that we go from very hot boiling water down to cold water is to, or down to freezing water, I should say, for the water bath, is to allow the plasmid DNA to get into the cell and then close it back up. So only 1 in every 10,000 cells successfully incorporates the plasmid DNA. But remember, there are a billion cells. So 1 every 10,000 for a billion is an okay efficiency. So the way in which you're going to do this is you're going to use this equation here, the number of transformants divided by that is a microgram of DNA. All right, final volume of recovery in milliliters and the volume plated in milliliters here. So what you're going to be doing is you're going to do the number of transformants, which is from the picture that is on the Google Classroom. Here I am in the Google Classroom. Here are the lab results. So this is a picture from my plates from when I did this lab, and you'll see that if you couldn't tell, this is the LB only plate, and there should be a lawn of growth on this. This is the LB amp plate, and so you should see that there's no growth on this plate. On this plate, you should see the LB amp, that there's growth, but they're not glowing. So the colonies were not transformed because they were missing the IPTG. But here you should see on this last plate that, yes, the bacteria is both growing and glowing. So what you're going to do here is count the number of colonies that you see on this plate, and that is going to be your numerator here. All right, so when you're here, the number of transformants, that's the number of glowing colonies you see, divided by the micrograms of DNA, which you're going to use here, 0.05 micrograms of DNA is used in this experiment. The final volume at recovery is 0.50 milliliters. So that's going to be your top here in your numerator. And the volume plated is 0.25 milliliters. So that's going to go in your denominator here. So the only thing you need to get from that picture is the number of transformants, and that's going to be a whole number, the number of glowing colonies that you see. All right, so that's how you calculate the transformation efficiency. All right, if you have any other questions, please email me or send them to me in the chat. I'll be available for office hours for you guys this week. If you have any questions on this, I had office hours already for this activity. So if you have questions on this activity, please email me so we can set up either a one-on-one or a small group time so that I can work with your group on this. All right, I hope that you are well. Thank you for asking for that.